Hi everyone, welcome to JavaScript and CSS for Geographers with Patrick Arlt, Nate Bedortha, and I'm Allison Davis. There's a link here to our slides if you'd like to follow along, and let's get started. So this talk is all fundamentals. This is a very quick kind of flyover introduction to the fundamentals of web development, HTML, CSS, and JavaScript. So we're going to cover a lot of ground today. And first, just a few notes as you're going through these slides and following along with us. There's a lot of supplemental info in these slides. It's really designed to keep you learning beyond this talk. Pretty much everything that we mentioned in these slides is a link, so you can link out to some great resources and keep learning long after this presentation is over. So definitely check out the slides and the interactive examples we've included. This is definitely a lot of material to cover in a pretty short amount of time, so don't worry if things don't make sense right away. We really want this to be a resource that you can come back to. So web development is hard. There's a lot to learn, there's a lot going on, and it's totally okay to feel overwhelmed. I certainly feel overwhelmed more often than not when developing. And the good news is that you're more equipped than you think. The technical knowledge that you have already from GIS translates very well to web development. So if you scripted with ArcPy or Python, if you've configured an application before or used Arcade or Model Builder, you've already got some great technical tools in your toolkit to really get you started and help you hit the ground running with web development. So a quick note on web servers, HTML, CSS, and JavaScript all go into a web server. And there are some instructions here linked in the slides on how to set up a local web server on your computer so that you can view static content in a browser on your local machine. So using this locally doesn't mean that you're serving pages on the internet for all to see, although you can certainly do that. You can also just use a local web server to load your own static files. If you're not comfortable on the command line, we've got some great resources at the end of this presentation on the resources slide for further learning. Or if you're in a hurry, you can use an online environment like CodePen or StackBlitz for prototyping. There are a lot of options out there that can help you hit the ground running with little or no configuration. So HTML. HTML is, if you will, the Lego bricks of front-end web development. These are little pieces of content that we put together into a document, and they make up the markup or content that you see on the web page in front of you. So this is a basic HTML document. The title tag here, you see this one says hello inside of the head tag. This is the title that you'd see in the tab of your browser when you're looking at a web page. The title and the link tags go inside of the head tags. Link tags are where you're going to either link out to a CSS style sheet, or you can also write CSS inline inside of a link tag. And then here inside of this body tag, we have content. Here we have a header saying welcome and some more unstyled content. And then any other content just continues to flow inside of that body tag. And then script tags, or where we link to JavaScript, goes right before our closing body tag. And the order here is pretty important because web pages load in order. So if a bunch of HTML content, like what's in our body, loads before your CSS, your user is going to see your unstyled HTML flash on the page before all of your nice typography, colors, fonts have a chance to load. So that's not a great user experience. And then also, if a script is loading before HTML and CSS have loaded, the page will be blank and it'll appear to be blocked while that script runs. And that's also a bad user experience as well. So there's a lot more to HTML. You can try out this starter code pen we've created for you in the slides, and that just allows you to mess around with getting some HTML onto the page here. And we also recommend checking out the Mozilla Development Network's HTML documents and guides. These have tons of great resources for getting going with HTML and getting started in the big wide world of web development. Now I'm going to turn things over to Nate Bedortha, and he's going to take us into CSS.
Let's talk about cascading style sheets. CSS is a language for specifying how HTML documents are presented to users, how they're laid out, what typefaces they use, and what colors different elements should be. But where does CSS go? A CSS file referenced by a link tag is the most common place. That way, many HTML documents can reference the same CSS document. You can also style a single HTML document directly by using the style tag inside that document's head tag. And as a last resort, you can put CSS inside an element's style attribute. Here's a single CSS rule. It's made up of selectors and sets of properties and values. The selectors select the elements inside the document. In this case, we're looking at the HTML tag, the body tag, and an element with an ID map. Properties are identifiers that indicate an element's specific stylistic features. Here we're going to change the margin, the width, and the height. Then each property is given a value that indicates your changes to that feature. In this case, we're setting the margin to 0 and the width and height to 100%. Style sheets are made up of many rules that are read in order. At the end of the document, the browser cascades every element's rules together and shows it to the user. Let's take a step back and talk about the C. The C is for cascading. The browser loads CSS in a specific order. Browser defaults, then linked style sheets followed by style tags and style attributes. The order of the rules matter, and the last rule in the source wins. Since the rules come from different places, you could be setting the same property to different values. That's where specificity comes in. When properties collide, specificity determines which property wins. Each type of selector is more specific than the next one. An ID selector is the most specific, and it can only match one element. A class selector can match many types of element, any element with that class name, and an element selector matches all the elements of that type. A crucial tool when writing CSS is your browser's developer tools, which allows you to modify any CSS and see the results instantly. For example, this story map is really beautiful, but we've been asked to make the design sing. Let's change the color of this text box and see what we can do. We'll right-click on it and choose Inspect. These are our browser's developer tools. At the top, we can see the entire page's DOM structure, including every element. And down here, we've got all the CSS rules for the selected element. So I've selected this text background, and the background is light. I like that, but I really want it to, as they say, pop. So let's make it hot pink. That might be too much. Let's pull it back to a salmon. Perfect. Okay, we've got a great idea for a web app. We're going to make a map that displays the locations of non-gasoline alternative fueling stations. How do we build it? First, we'll need to think about the layout. It looks like our design has two major components, a box for text information and a box for our map, along with a header and a footer. We can write some HTML to put these components on a page, but how can we move the boxes where we need them to go? We'll use the display property. By default, all elements have a display value of either block or inline. You can kind of guess what they do by the names, but let's look at some examples. Here's a demo with a lot of block elements. You can see that the block elements are laid out one after the other vertically, beginning at the top of the containing block, and most of their dimensions can be changed with different CSS properties. You can see here we're changing the width and the height of each of these, as well as the padding and the margin of these other elements. Let's look at some inline elements. Inline elements are laid out horizontally, one after the other, beginning at the top of a containing block. Since these elements are in line with each other, most of their dimensions can't be changed. You can see here that most of these margins aren't being applied to these elements. While we're talking about dimensions, this is the perfect time to mention units. There are lots of different units, but usually we're talking about length units. Length units can be either absolute or relative. Absolute length units represent an actual physical measurement, pixels, inches, or centimeters. And for a long time, we used pixels for every length. But as viewport sizes changed, we needed to start using relative length units, and they represent a measurement in terms of some other distance, the size of a specific character or the line height of a font, or even the size of the viewport. Let's look at some different units here. Here's a demo. You can see this block is sized with pixel elements, 250 pixels by 250 pixels. You can also use percentages, which is a relative unit, but you can't apply it to the height. Click on this link to find out why. Here's an M, here's a rem, and here's VH and VW units. These are very handy, and you'll be seeing a lot of them in the future. Okay, quick detour for the basics, and now we're ready to lay out our app UI. To do that, let's look at a layout model called Flexbox. Flexbox is a layout model optimized for UI design. Flexible boxes lay out their children along one dimension, either horizontally or vertically. Flex children can flex their size to grow or shrink without overflowing their parents. In this demo, you can see the map element will always grow at twice the rate of the sidebar element, and neither will ever break their parent's container. This gives us a lot of control over our page layout, but sometimes we need to position things a little more specifically. And for that, we use the position property. Position property allows elements to be positioned in a document relative to other elements. We can use it to overlap elements over one another. Notice in this demo, we're positioning 4 different widget elements over our map element. Flexbox and position gives us lots of layout options. But for maximum control of our UI, we want to use CSS grid layout. Grid layout is an extremely powerful layout model that can lay out entire page areas or the smallest user interface elements. The grid is an intersecting set of horizontal and vertical lines that allows you to define fixed or flexible tracks and easily place and position elements. In this demo, we'll use rules like grid column and grid area to have precise control over our layout. Wow, look at this. Our layout's really coming together. We should start thinking about how our app is going to look on a smartphone. Responsive design means that your layout responds to a variety of devices or screen sizes. We'll use special CSS syntax called media queries to apply different CSS rules to different conditions. For example, a user could be using dark mode on their laptop and your design could use a darker background color to match. But most frequently, we adapt our design to the size of the user's viewport. Let's take a look at this demo. Here we're using this @media screen and max width 768 pixels. So this means if the media is a screen and its maximum width is 768 pixels, we'll start using these CSS rules. So let's see what happens when we shrink this viewport down to less than 768 pixels. You can see that the map is repositioned to the top and the sidebar is repositioned to the bottom. This is a great layout for a phone. Well, our app's almost done, but before we send our prototype over to the JavaScripters for some logic, let's give it a fresh coat of paint. We'll load up some snazzy fonts from Google Fonts, and we'll use Typescale to generate a hierarchy for all of our typography. And while we're doing that, let's swing by the Adobe color wheel and create a new color scheme to really tie it all together. Here we're going to load 2 different fonts from Google APIs. And look at that. That makes our headlines look so much better. And I really like these color choices too. Okay, Allison, our app is all ready for you to add some JavaScript.
Okay, so we're moving on to JavaScript. Now, where does JavaScript go? As we've seen earlier, it can go inside of a script tag in our HTML, and you can just write that JavaScript code in line here. You can also use a script tag to link to a JavaScript file that's elsewhere in your application. You can also utilize the developer tools that Nate demonstrated earlier, and you can actually open up the console there and write JavaScript directly into that console. So what this looks like, we can do this right here in our slides. Let year, and then if we say year, we have a value of 2020. So you can just write statements immediately and see feedback immediately as you log those out. So that's pretty handy. So we're going to talk a little bit about some basic syntax and operators. You can follow along and try this stuff out in CodePen. I also really recommend checking out the Mozilla Developer Network's JavaScript guides and tutorials. They've got some really great content when you're digging into JavaScript syntax and code flow. And I'm going to keep our console open here because as you can see in this CodePen, we don't have any HTML or CSS content. We're just writing some JavaScript that's going to evaluate to the console. Go ahead and refresh the page. Great. So we can declare variables or stored values that we want to reference later in code with a few different keywords. We can use var or let, or we can also use the keyword const. That's a special keyword for variables whose values are not going to change later on in our application. So use that keyword a little more sparingly or carefully, because once you assign, say, dog name is equal to Bunsen, I can't later in my application change the dog name to a different value like Spot. It's got to stay the same. And one of the interesting things about JavaScript is that it actually infers the types of the values that we're setting our variables to. And what that means is that you don't have to tell JavaScript, when we set this variable dog name equal to Bunsen, we don't have to say to JavaScript that this is a string. JavaScript infers that, and so if we log out type of dog name, we see in the console we're getting back string. So that's kind of handy, and sometimes can lead to some odd bugs, but sometimes gives us a great deal of flexibility when we're working in JavaScript. And it's important to note too, strings can go in double or single quotes. Numbers and Booleans, that is true or false values, do not. We can also do math in JavaScript. So we see, for example, we're logging out our year variable, which we set up above, year plus 5. We see that's equal to 2025. Here, when we log out year divided by 3, we get this nice repeating decimal. Now, a thing to take note of that's really important, when we log out math.round and we pass our variable year here, we don't get this last value, 673.333, rounded. We actually still get 2020, and that's because when we're performing these operations on our year variable, the variable itself is not changing. It's actually logging out a new value. So if we wanted to have this value persist in code, we would do something like let year plus 2020, and then we say math.round new val. And as you can see, we get 673. So that actually rounds this new value, which we've now stored as a separate variable, so we can refer back to it. We can also use these increment and decrement operators, the plus plus or minus minus, that will increase or decrease a variable by 1. We can also do things like concatenate strings. So for example, high plus 5, not surprisingly, returns high 5. We also have comparison operators. So for example, 3 is less than 1, will return false. Year is greater than or equal to 2020, will return true. This is the strict equal sign, so year equals 2019 would return false. And also, unsurprisingly, this is the not equal to, so the string dog is not equal to cat, that will return true. We also have some logical operators as well. So these are really handy if you're declaring a condition to be true or false in your application to then execute some code or behavior in your application. So for example, we can join two conditions together. So true, and then the double ampersand, which is the and operator, and our variable sky blue. So two trues will evaluate to true. Here we have the double pipe or operator, true or false, that will also return true because it's an either or kind of thing. And then we also have this bang or exclamation sign in front of a variable. You can use that to say the opposite of whatever value you set that variable to. So sky blue is equal to true. So if we were to log out bang sky blue, that would evaluate to false. So you can play around with all of these either in CodePen, which we've linked to, or you can also just crack open your browser's developer tools and try these out for yourself in the console. So functions. A function is a piece of functionality or code that we're going to run and potentially run more than once in JavaScript. And a function definition consists of the function keyword, which we see right here, and then the name of the function, a list of the parameters inside the parentheses. So here we have the parameter age. There can be more than one. Inside of these curly braces is the code that's actually going to run when the function is invoked. The return statement here refers to the value that's going to be returned by the function. And so in this example, we're passing in a parameter of age, and then this function returns a value of the age parameter multiplied by 7. And it's important to note, defining a function doesn't execute it. So if you actually want to call this function and have an actual value be returned, we need to call it underneath. So here we have function dog years defined, and here we're actually calling that with the argument of 3, and then that will evaluate to 21. Functions can also be anonymous, so this is a named function. We've given it a name, and then we can refer to dog years later in our code and call that function as many times as we want. But we can also have anonymous functions, and functions, whether named or anonymous, can even be passed as arguments to other functions. We'll talk a little bit more about that later. Arrow syntax is just another way of declaring a function as of the ES6 standard. So it's a little less verbose than using the function keyword as seen here. So you can just use the parentheses, you still have your parameters, and then you have this nice arrow sign here, and then still in our curly braces, the return statement and then age times 7. We can shorten this up even more and make it even terser. If we have one argument like we do, or one parameter, excuse me, like we have here, you can even omit the parentheses, still have the arrow, and then we can get rid of these curly braces. Since we just have one line and it's returning, this return statement will be implicit, and we can just have age times 7. So that really can help when we're passing around lots of anonymous functions that are just returning values. This can really help clarify or neaten up our code. Okay, arrays and objects. So these are some data structures that you'll see a lot in JavaScript and other languages as well. So we're going to crack open a code pen here. So arrays are a way to store a list of items under a single variable name. So here we have dogs array. These are my two dogs, Ginsburg and Bunsen. And this allows us to store multiple values under one name. And we can do get a lot of interesting information from our array. We can console log a length. So in this case, get that to refresh. So in this case, the length of our array is 2 because there are 2 items inside of it. You can use an index value to extract single values from the array. So for example, if we were to log out dogs array at the 0 index, that would return the string of Ginsburg. Arrays actually start at a 0 index. So 0 is the first item, 1 is the second, and so on. So that's something to be aware of when you're using an index to get a specific value from an array. We can do things like add things to an array. So say I've gotten a third dog named Spot, and we can push that into the array. And then you see if we log out the length of our array, that's changed to 3. And also we can see that we've got our new array, Ginsburg, Bunsen, and Spot. So we now have 3 values there. The interesting thing is that some array methods like push modify the existing array that we've set to that variable, and others return a new array without mutating original data. So one example of that is the map function. So here in code, we're setting a variable uppercase dogs, and we call .map on the dogs array. And what this is going to do is take a function, and it's going to apply that function to every item in the array, and it's going to return an array of just those new values. So what this is going to do, we're going to iterate over every dog in our array, and we're just going to return the value dog to uppercase, which is a built-in string method that, as you might expect, returns a string in all capital letters. And so when we log out uppercase dogs here, we see that our values have changed to all capital letters, but then our original array is left unchanged. So that's really handy as well when you're working with data in your code and you want to maintain an original array or set of data, but you also want to make some changes and maybe pass those values along in your application. Really handy to keep in mind when you're thinking about whether to mutate data or keep it in place. So objects, you see, are noted by the curly braces here instead of the square brackets. And objects are a collection of related data. Objects can have properties or values and methods, which are functions. So in this example, again with the dogs, because I'm a dog fan, we have a dog object with the name of Ginsburg, and then we have an age in dog years method that returns this function, which again is just a function that takes an age parameter and then returns age times 7. And we can access properties with dot or square bracket notation. This looks like the following. These do exactly the same thing. We can say dog.name, and that will give us Ginsburg. And we can say dog and then square brackets. Now this is important. You have to pass that property name inside of a string if you're using square bracket notation. And you can say dog square bracket name and then also get Ginsburg. And just like any other function, we can call an object's methods. So for example, we can say console.log and then age in dog years. So again, just like our other examples, we've got all of these little instances for you to play around with in CodePen. Recommend that you check those out. And now I'm going to hand things off to Pat, and he's going to talk to us about common patterns that you'll see when working with JavaScript in your web applications.
I'm Patrick Arlt, and now that you have some of the basics of JavaScript down, I want to dig a little deeper and show you some things that you'll commonly see when you're building applications. And the first thing I want to talk about is I want to talk about kind of the internals of how JavaScript works. And this is important because JavaScript is what programmers will refer to as asynchronous, meaning the code doesn't always operate in the order that you specify. And this is largely because you're always reacting to lots of things. Maybe the user is resizing the window or they're clicking a link, and you want to be able to respond to that outside of kind of the normal flow of how you're writing the code. And how JavaScript does this is it is what we call single-threaded. It only does one thing at a time, and it runs one function at a time in its entirety. And when that function is done running, then it runs the next function in this big loop. So when you actually call a function in JavaScript, it goes to the back of the event loop and waits for all of the other functions that are currently a part of the loop to finish. And a lot of times you'll find yourself defining what are called callback functions, which just simply define a function that's going to be run later. So let's take a look at that first. I wrote a really simple program, which is this function called go, and I call it down here at the very bottom. And when this function gets called, the first thing that's going to happen is we're going to console.log hello dev summit, which you can see is the first thing that happened in my console. Then we need to run this function in its entirety. So we're going to call the setTimeout function, which is a function that takes a function as an argument. And this function is going to be run in 100 milliseconds, or roughly 100 milliseconds. And that's going to log let's learn to the console. And this function is usually, when you pass a function to another function, that's usually what was referred to as a callback function. And we're going to do that 2 more times with a 10 millisecond delay and then a 0 millisecond delay. And it's important to note, even though the 0 millisecond delay is there, that doesn't mean it's immediate. JavaScript still wants to finish running this go function before it picks up one of these 3 callback functions. So the last thing it does is it prints thanks. And you can see the thanks in the console. And then 0 milliseconds later, because there's nothing else going on, there's this async that's logged, and then JavaScript, and then let's learn. So this is an indication that things can happen out of order in JavaScript. And this can get really complicated. If you have, maybe you need to make multiple requests to an API for data, or you want to know when 2 or 3 different layers have loaded in the JavaScript API. This can actually get really complicated. And a way to manage that is with something called promises. And a promise represents a value that's going to be given to you in the future. And a really common use of promises is actually requesting data. So let's take a look at a random API that I'm using called Pixum. And this is actually just going to fetch 5 random photos from the Pixum API. So you can use this built-in function called fetch, and fetch returns a promise. And a promise has 2 methods on it that you can call. It's an object. And those methods are then and catch. And you can see me calling then. I want to process the response. Then I want to do something with the data, and I want to catch any problems that might occur in these functions. So that promise is going to be returned from fetch. Then I'm going to call the then, and I'm going to pass this process response function. And that gets the promise. So the response isn't actually the response. It's a promise of the response. And on that, I can call different methods. And this is going to vary depending on what the actual promise is. I'm going to call JSON. So I want to process this response as JSON. And that's going to return another promise, so I can just keep going. And when I get that promise, then I want to do something with that data. And what I'm going to do is I'm just going to console log the first URL of the first image. And that's going to just give me this unsplash photo URL. Now, if anything had gone wrong in any of these two previous steps or in fetch itself, we would get this handy error function, and that would let us catch any errors and respond. Maybe we'd show an error message, maybe we would retry the request. So chaining promises together like this, where you have multiple functions that just keep returning promises, is actually really common, especially when working with the JavaScript API. Now, taking these two things together, we can start to actually interact with web pages. We can request data from APIs, we can interact with our HTML page. And JavaScript interacts with HTML through something called the DOM, which stands for Document Object Model. So all of your HTML content is accessible through JavaScript, and you can find specific pieces of that HTML, say a button or a div, and you can wait for things to happen to that. You can listen for when users click, or when the mouse enters, or when the user resizes the window. And in response to that, you can change different things about your page. So I have this demo, and we can see that I've put together a form where I can kind of fill out this little form. And then when I submit it, we can actually put what I filled in the form there. Now, I might want to send this to an API. I might want to do some other things with it. So we just have this form. We're going to request some CSS, and then we're going to build out a little form. And each of these form inputs has a name, which corresponds to the key that we want to use in our object. So what we're going to do first is we're going to use the document query selector method. Document is the root of the DOM, and we're going to select the element that matches ID of form. Now, this is the same thing that you learned in CSS, and there's multiple ways of finding elements in the DOM, and query selector just gets you the first thing that matches. So that's going to get our form element, and we can log that to the console. And as a handy thing, when you log HTML elements to the console, you'll usually get this helpful little hover, and it'll actually show you the HTML rather than the JavaScript object. And it'll show you all the stuff in that form. And then we want to add an event listener to the form. So when we add an event listener, we're telling the browser that we want to respond to something. In this case, we want to respond to when a user submits the form. So when the user submits the form, the first thing we want to do is we actually want to prevent any default behavior that that form might have. In this case, usually when you submit a form, the browser tries to send the form to a server. We don't want that to happen. We want to intercept it and put it in this console. And then we'll make a new form data object. And the form data object is just a browser helper. It takes a form, which is the target of our submit event, and it processes all of the data. So we're going to make an empty object, we're going to hold the data, and then we're going to iterate over each piece of data in the form, and we're going to build our object. Now, one neat thing that you can do, in addition to using console.log, is you can insert a debugger statement. And the debugger statement is fairly special. So when I submit this again, you'll see that my browser actually says paused on debugger statement. And this is actually stopped my application right here at this piece of code. And what that's doing is it's letting me look at the code, and I can actually interact with it in my console. So if I want to actually know what this data object is, I can actually look at the data object that we just built in this statement. And I can see that the data object is correct. And I can then look at maybe our form data object. So this is our form data object. It's currently just looks like an empty object. I can look at what are all of the defined variables in this particular function. So you can actually look at and kind of stop and poke around with things quite a bit in the debugger tools as well. So, and when then I hit resume, it's actually going to keep running my application, and then you can see that it updated that again. So this is how you can actually start to interact with the browser using JavaScript. And there's a lot of methods in the DOM. I just kind of gave a high-level overview. You're going to want to spend a lot of time learning what you can do with that. So as you build more and more complex applications, you're going to want to start to break things up into different files. And there are two ways that I'm going to talk about doing that. There's actually lots of different ways, but these are the two that are the most important. And the first one is JavaScript modules. And if you saw during the plenary, Jeremy talked about this is coming to the JavaScript API very soon, right? This is the actual JavaScript standard for how you would do things. So if we go back to our demo, this looks fairly straightforward. We kind of have the same form and we can fill it out. Maybe this, and then we submit it. And when we reset, it actually shows the results have been reset. So this behavior is actually split up between three different files. We have an index.js file, we have a form, and we have an alert. And the form and alert are actually just the same thing that we showed in the previous demo, but we're exporting a function. So we're going to export something from this file, and then that function can be imported into a different file and then called. So in this case, we're going to import everything as a variable from another file, and then we can call that as an object. So we have a form object, which represents all the exports from form.js, and we're going to call the setup method on it. So that's a quick way you can break up files. And in terms of this index.js file, it actually just gets included as a script tag. And it's actually getting automatically included here in this particular document by StackBlitz. That generally won't happen, but you can specify script src equals index.js type module, and that'll get included. Now, the way that the JavaScript API works today, right now, is using AMD modules. And you'll see this all over the place where there's require, and then there's a list of modules, and then there's a callback function once those modules have been loaded. And this is pretty standard. This is a way of doing this that's a little bit older, but it definitely works. It's essentially inserting script tags for the Esri map and the Esri views map view module onto the page. So we're going to require, and then we have an array of modules, and then we have a callback function. And when this callback function is run, we're going to get those modules as parameters of the function. And then we can actually call them. So we know that the map and map view modules have been loaded, and then we can instantiate our map, and we can give it a base map. We're going to use streets navigation vector, and then we can have a map view, and that map view is going to look at our view div, which is in our HTML, and that's going to use our map. So let's finish up the app that we were working on in the CSS. So we had this layout already kind of built out. We had some text, and we wanted to bring in a map with the JavaScript API. So the easiest way to do this is we're going to include the JavaScript API CSS, which is the link tag, and we're going to include the JavaScript API itself. We're using a pretty old version here. So this script tag loads the JavaScript API, and we have access to the require tag. So we're going to require 4 modules. We need map, map view, feature layer, and search. And when all 4 of those modules have loaded, we're going to run this callback function, getting map, map view, feature layer, and search as arguments. So we can create a new instance of the map class. We're going to use dark gray vector. We can create a new instance of map view, which targets the div that we want to display the map in. We create a new feature layer, and then we add the feature layer to the map. And then we can create a new search widget, and we can add that to our div called search, and then we can call the startup function. So this is going to let us search for places like where I live in Anaheim, so I can quickly zoom in on what's around me. So overall, this doesn't require a ton of work, right? There's only about 30 lines of JavaScript here, and you can actually write quick little apps with the JavaScript API really, really simply and easily. So what about something a little more complex? I'm going to step through a fairly complicated sample from the JavaScript API on chaining promises. And this is a really good one because it shows pretty much everything that I've talked about in this section so far. So we have a globe, we have a scene, and then we have a start promise chain button. And when I click that button, it zooms in on this crater. It does some calculations. It tells me this crater is about 317 acres. So we have an HTML document. We have our map view div, which is 0 padding, 0 margin. It's 100% wide and high. And then we have our little results div that floats over the top of it. And we're going to require quite a few different modules. We're going to require geometry engine, point graphic, graphics layer, map, and scene view. And then I'm going to skip to a bit of some of the interesting code. So there's a function on map view and scene view called when, and this is basically when the view is ready, do this. And we're going to give it a callback function. And when the view is ready, we're going to get our start button, and we're going to add an event listener to it. And when we click that, we're going to run this function, which is starts a promise chain. And as a part of that promise chain, we're going to start by calling geometry engine async, and we're going to buffer the point where our meteor is, and we're going to buffer it by 700 yards. Then we're going to add the graphics to the map. Then we're going to zoom to those graphics. Then we're going to calculate the area of those graphics. And then we're going to print that area to the screen. And each of these is a function that returns a promise. And as long as you keep returning a promise, you can keep the chain going. So we're going to add the graphics to the map, and then we're just going to return the same buffer that we got through. The buffer is a promise, so we can call then on it. And then we're going to zoom to, and that gets our buffer, and then that's going to just sort of keep going. So then that's going to return another promise, and then that's going to keep returning promises all the way down. So take a look at this sample and see if you can understand it on your own. It's a great example of what you can do with the JavaScript API. So to close out, I want to talk about tools and JavaScript frameworks. And there are a lot of tools, but I think it's really important to establish that you can do most things with just the JavaScript API. And you don't really get a lot of benefit by trying to overwhelm yourself by thinking about using every tool or every framework right off the bat. And you can tend to build things that are really complicated to manage when you really don't need to. But to give you an overview, I'm going to just talk through some of the common types of tools. So we've already talked about modules a little bit, and that's for splitting up and sharing code. And there are others like compilers, like TypeScript, which add features to JavaScript and transform code into other code. And you'll often see bundlers next to modules and compilers. This would be something like Webpack, which might bundle all of your different modules, but it also might have a plugin that runs Babel or TypeScript to transform the code as it bundles it together. And on top of that, you may have frameworks like Angular or Vue, which give you kind of architecture and structure for big projects. So those are some of the examples. You can see we already talked about JavaScript modules and AMD modules. Now, most of these tools, they're going to run in Node, so it might also be good, though, to familiarize yourself a little bit with Node.js. And you can actually do some neat things, like you can actually write command line tools or web servers. And when you install Node.js, you automatically install a package manager called npm, which, if you've used Python, is probably similar to pip or conda, where you can install other people's JavaScript code. And these are some of the development tools that we kind of recommend using for JavaScript development. Again, there's do I have a web server running? Some of the prototyping tools we showed in this talk were CodePen, JSBin, and StackBlitz. A lot of people are using Visual Studio Code now, links to your browser developer tools. And then as a final thing, if you really want to dig into kind of the tools side of things, start with the ArcGIS JS CLI, because it does a lot of the pre-configuring for you in terms of getting all of it set up correctly. So it makes for a good jumping on point. And finally, we have a whole set of resources to kind of keep you learning. These are all things that we've kind of vetted and we recommend for people, and they're kept up to date pretty well. And this is the final slide URL. Thank you for watching.